Then we have three factors, three big factors. There are a lot of smaller factors that affect the overall physical state of a substance, whether it's a solid, liquid, or gas. Three factors. Okay? Factors that affect the physical state of a material.
It's like a Venn diagram.
It is a Venn diagram. Exactly what it is.
I knew it!
There's three of them, so it's not a Venn diagram.
It's on steroids.
It's like a,
Tom, you're on steroids.
it's an interlocking Venn diagram plus.
You're good.
This is a type of Venn diagram.
You can have three circles.
You can have four. The number of circles doesn't really matter. It depends on what you're dealing with. In this case, we're dealing with three.
Tom just shot me the bird.
Yep.
Okay, so the strength of attraction between particles is one of those factors. Okay? Another is how fast the particles are moving.
I think I remember seeing that in our homework.
You think? So that has something to do with temperature, doesn't it?
Would this be called a Venn triagram?
Because temperature is
How fast particles move
in a random fashion.
in a random fashion.
Okay?
Oh, that produces
And we also said that it has to do with the size of them,
shape.
the size and shape. Okay? So all of those will affect whether something is a solid, liquid, or gas. Okay? If we increase the attraction between particles, you tend to have solids as opposed to gases. Okay? And if you think about it, gases are the least organized of the substances we have here, solid, liquid, or gas. Liquids are a little more organized, liquids. And then solids are the most organized, and actually crystal solids are the most organized of the solids. But we're just going to stick with those three for right now, okay? If we increase the strength of attraction, then we tend to go in this direction, toward the solids. Okay? If we decrease the strength of attraction, so instead of maybe being a dipole, we're going to go to a non-temporary dipole state, we tend to go toward gases. If we move the particles faster, they tend to go this way. Okay? If we decrease how fast the particles are moving, they tend to go this way. And that makes sense if you think about it. You know, when you cool something down,
It freezes.
it freezes, or if it's a gas, it liquefies. Okay? Size and shape of the particles. The larger the particles, the more likely they are to be solids. The smaller the particles, the more likely they are to be gases.
Oh, yeah, that makes sense.
Does that make some sense? All of those have an effect on what the physical state of a material is. And all of those, it's really important for you to keep all of those in mind when you're trying to figure out, well, which situation is going on here, whether this is likely to be a solid or liquid or gas. Now, I'm not going to actually give you, say, a temperature and the size of a molecule and say, okay, and that sort of stuff, and say, is it a solid, liquid, or gas? No. What I'm going to do is I'm going to give you different molecules or different chemical formulas and say, which one of these is more likely to be a gas or a solid? That sort of thing. So relatively speaking. Okay? I want to know that you can understand this idea.